All right. So we are talking about exponents. It was not, I would say, not originally in my plan to go over this whole section with you, but just based on some of the stuff we've done, I feel like I'm seeing some gaps. So I just really want to make sure we're solid on exponents and square roots and stuff like that before we really go any further into the solving equations. So I'm kind of pausing on the solving equations. We'll move to this, and then we'll go back to the solving equations a little bit later. So when we're talking about exponents, okay, in the case of repeated multiplication with the same number, we can rewrite the expression using exponents. For instance, if you have 4 times 4 times 4, okay, you can rewrite that as 4 to the third power. How else would you say that, Joey? 4 to the third power. Cubed, okay, 4 cubed. So when we're talking about if we just have x, okay, to the second power versus x to the third power, okay, the first one we could say as x squared, okay? Reason being is because if we think of a square, what is the characteristic of a square? All of its sides are the same length, right? Okay, so if we have 2 right there and 2 right there, how would you find the area of a square? Multiply them together, okay? 2 squared, so 2 times 2, okay? So what do we think x cubed would represent? A cube. Let's pretend that I know how to draw one. Okay? It's kind of a cube. Don't judge me.
It just looks really big.
Well, thank you. There. That's a little better. Okay. I said a little.
Yes.
Wow. Okay. So for a cube, it's the same thing. All the sides are the same length, but now we're going 3-dimensional. So it could be 2 for the height, 2 for the length, 2 for the width. Okay? So 2 times 2 times 2. So you would read an exponent as x to the nth power. So x to the second power, x to the third power, 4th, 5th, 26th, 87th. Okay? However high you want to get. So the large number, okay, the big number in an exponent is called the base number. And then the superscript, okay, the small number up top is the exponent. So let's look at how these all these expressions are related. So in the first box, you have the expanded notation, which just means you have the base number and how many times you're multiplying that base number by itself. So if we look at number 1, we have 11 times 11. So how many times are we multiplying 11? 2. So we can write that as 11 squared. And then the value of that is 121. How do you get the value of that? By multiplying it together. Yep. So for 2 to the 7th power. What's that going to be? 64? 49? 2 times 2 is 4 times 2 times 2 times 2 times 2 times 2. Right? 4 times 4 times 4 times 2. Yeah. So 128. There you go. Okay, so for the rest of this table, I want you to do, on that first page, I want you to fill out the rest of the, let's do odd numbers. Odd numbers. Okay, see how you do filling out the odd number tables, and then we'll check them in just a sec. Help each other out. You can cross them out if you want to, but you don't have to. No. Yep. For which one? 3136. Yep.
Really? It's that big?
625. 6, 2. Dang, that's a big number. Go on me. How do you put that number? I like
So then, I don't know what the back leg.
yeah,
I don't know how to like yeah, that's too.
I didn't know that. What are you doing? What do you want to do that?
Baby little.
Whoa. Look at that. I forgot to do that. How the heck? I forgot to do the arrow.
Yep. 5 times 5 is 25. Times 5 is 125. 125 times 5 is 60.
One over 64.
Oh, he is.
I got 1 over 64. Wait.
Is that really?
Where's the question that one?
So if
I'm
you
going
go back to
So what number do I have?
So bad. What about here? We just like celebrate this.
right there, so because
Because
they're gonna be multiplied together.
5 times negative 5 times negative 5 times negative 5 times negative 5. I just did negative 5 times negative 5 times negative 5 times negative 5. What I could have done. Negative 5 times 5. I don't care. Wow, I'm not
It's the dedication.
Yeah.
I have a question. If a negative is multiplied by a negative, is it positive?
Always.
Yeah.
You said what's a
It is 20.
It is.
It's a big number.
Negative times negative equals positive.
What's up?
Would this be negative 625?
Say that one more time.
Negative 625? I know, but you do
What?
negative 5 times 4.
Who's that for?
What?
Who's that for?
You. For the hat.
No, from. What are you talking about? That's from hearing?
Wait.
Okay, hold on just a second.
Negative 5 times negative 5 times negative 5 times negative 5.
Omar, did I already give you a break? Other than Katie, did I owe change to anybody? I don't think so.
Mr. Bennett.
Pre-Algebra.
Really easy. Really?
I'm trying to go back on the algebra.
I'm very excited to explain this to you.
I'm confused the number 5. What is it to the power of 4 or 7?
Hey, Vincent, will you go grab did y'all write your names on that sheet?
There's 25 here. So it's
What?
25 here, right?
No. I don't know.
25 times 5.
I don't know.
So you don't know how much money was in here.
Oh, it's like $5 or something.
It was more than $5.
Yeah.
Oh, that's crazy.
Yeah, I just saw you.
I just did the
Vincent, bring your
I don't know what it is.
Is that you're asking me to plug it on?
Yeah, so you should put X1.
You just go ask the sub for this sheet. Just take that over there and say, can I have this sheet? And then we'll turn it in.
Wow.
All right, guys. Let me put the solutions up here so we can check ourselves. So, if you are struggling so far, there's a couple things I want to point out to you. Okay. Only odd numbers, yes. Okay, so your calculator does not look exactly like this, okay, but we have similar functions. It is my TI-84 plus calculator.
TI-84 plus calculator.
Yes. If I wasn't recording right now, I might tell you that. Never mind. I'll get in trouble. Once I get done recording, thank you. You know.
It's very,
I wanted it at math camp.
It looks like a TV remote.
Bye, Vincent.
It's over my face.
All right. Let's try and wrap this up, guys, so y'all don't have homework, right? Okay. Vincent, I love you. Go away. Hey. All right, guys. Do we want homework this weekend or do we not?
No.
It's either focus now or you have to focus on Saturday or Sunday. Okay. So let's focus now. Okay. On the calculator. Katie, can you sit down while you're doing that? On the calculator. Okay. When you are working with exponents, and really when you're working with multiplication at all, and negative numbers, it's very important that you punch your stuff in correctly, or your calculator will not compute it the right way. Calculators are very smart, but they're very literal, which makes them have little common sense. Yes, exactly. They're book smart. We'll say calculators are book smart. Okay. So if I have -5, okay, do what? You can, yeah. Go ahead. If you've got a calculator in front of you, or at least if somebody sitting close to you does, type in -5. Okay, if I type in a -5, and then I put it to the 4th power, in my head, do I feel like I know if my answer should be positive or negative? What do we think it should be? We feel like it should be positive because we're going to be doing an even number of negatives, right? But if I hit enter, it gives me a negative number. Why?
You didn't do like separate. You didn't do like 5 times 5 times 5 times 5.
What the calculator sees is negative times 5. So sorry, times 5 to the 4th power. And so we know order of operations wise, what is the calculator going to do first? The exponent. They're going to do 5 to the 4th power and then multiply it by a negative. Okay? What you really want to do is parentheses, negative 5, close parentheses, to the 4th power. Now you're telling the calculator, hey, I am taking this negative 5 to the 4th power, not just 5 to the 4th power. Then you hit enter and it'll give you a positive number, which is what you want. Okay? So always, always, always use parentheses when you're working with exponents. Okay? So let's flip back. Yes, but you want to be sure that it's not supposed to be, because sometimes it might be. Okay? All right, so number 3. Okay, our exponential expression should be negative 5 to the 4th. Negative 5 to the 4th. Okay? If you don't write it with parentheses, that's the difference between you getting a 4 or getting a 3.5. Okay? Because it's really important that we remember that. What's the value? 625. All right, number 5. Exponential expression wise, we could write it 7 squared times 4 to the 3rd. All right, so what's 7 squared? 49. Okay. What is 4 to the 3rd power? 64. What's 49 times 64? Say that a little louder, Cohen. 3,136. Okay. With number 7. Okay, this one's a little weird. We'd have 2/3 squared times 9 squared. What is 2/3 squared? Yeah, 4 over what? 4 over 9. Okay. Times, what's 9 squared? What? 81. Let's focus, guys. 81. Okay. So now to finish this problem, if you punch it all into the calculator, that's perfect. Okay. If you're trying to do it by hand, you do 4 times 81, which is 324. Okay. Over 9. What's 324 divided by 9?
How'd you get 49?
So that's a good question. So we have this 2/3 squared right here, Alex. Okay. So when you do 2/3 times 2/3, you got to multiply across. So 2 times 2 is 4. 3 times 3 is 9.
What about 81?
The 81 came from the 9 squared. I just put it over 1 because we were multiplying it with a fraction. Okay? All good questions. Yeah. 9. And now we've got some variables. So how's this going to look? Yeah, so this one's another important one when it comes to parentheses. Okay? If I just write it like this, what I'm really saying is x times y to the 5th. But that's not what we want. What we want is xy to the 5th. Okay? So make sure you got that parentheses in there. What's the value? What's this final answer? Yeah, same.
I'm so smart.
Okay? There's no simplification that can be done because we don't know the value.
Why'd you make it parentheses?
That's a good question. So the reason you're putting it in parentheses is kind of the same reason we do the negative like that. If I write it out like this, okay, what that actually is right here is x times y to the 5th. So the only variable that you're actually taking to the fifth power is the y. But you want to do both. Yep.
Does it matter if the 5 is in the parentheses or out of the parentheses?
It does actually, yeah. If you put it inside the parentheses, you're still only doing this portion. Okay? When you put it outside the parentheses like this, the parentheses are kind of notating that you are taking the fifth power of everything inside the parentheses. Okay? So if you wanted to put the 5 inside the parentheses, you'd actually have to write it like this. Okay? Because you want to take the fifth power of both. So 11 and 13. So how many K's do we have? So we've got 9 to the third power. K to the sixth power. What is 9 to the third power? 729. K to the sixth. Okay, and then the last one, you're going to see factors like this in Algebra 2 all the time, which for you will be your junior year of high school. Okay, P minus 2 cubed, or to the third power. Same Z's on this one. No reduction. Okay? Okay, we're going to move on. Yep. On both of those spots, the P minus 2, it is the same because there's no, we don't know the value for P, so we can't simplify it at all. So like, the point of writing it is so that you just learned that sometimes the exponential version is the most simple that it can get. But like when we're working with like number 5, we have those numbers 7 and 4. There's nothing unknown, so that's why we can multiply all those together to get a one singular. You putting in what? So somewhere, it's ignoring the number. It's just all right, guys. Let's keep rolling. All right. So we're going over a few exponent rules. Okay. So a lot of this is just going to be some memorizing that you have to do. Okay. The same reason that you can roll through your multiplication facts without having to think about it is because you just repped it. Okay. These exponent rules will get to that point where you'll know them. Probably not as well, but all right. Any number. Come on. All right, sorry about that. Any number except 0 raised to the 0 power is going to be what? Does anybody know? It's going to be 1. Okay? It's a weird rule. So 1 to the 0 power is 1. 2 to the 0 power is 1. 3 to the 0 power, 1, 1, 1. So what that is saying is that in this last example right here, this rule is applicable as long as x does not equal 0. Because 0 to the 0 power would not be 1. And so that's why it's specified. It would be 0. Yep. Okay. Negative exponent rule. Okay, so if we have x to the negative n power, that is going to equal 1 over x to the n. Kind of zoom in on that. So, for instance, okay, and this is frequently missed, okay? Let's say we have, I'm going to say we have x to the negative third power. It's just like 10 seconds behind me.
What does that mean by the
That means it as long as x does not equal 0. These rules apply except for if x equals 0, basically. Okay, so x to the negative third power is the same as 1 over x to the positive third power. Okay, so looking at the few rules that we've talked about just a little, I would like for you to do, not all of these, we'll just keep it the same and we'll just do the odds. Okay, odd numbers for the rest of your notes, odd numbers for your homework. Odd numbers for the rest of the notes, odd numbers for your homework.
So we can what?
Yes.
Wait, even on the homework?
Odds. Odd numbers. Mm-hmm. Odd numbers are 1, 3, 5, 7, 9, 11, 13, 15. Okay. Okay.
Whatever that means. Odd numbers is homework. So.
Well, that's the only homework.
Well, so is this 5?
So it's 5 to the negative 2, and it's going to be 1 over 5 to the positive 2. And what's 5 to the positive 2?
Something.
So it should be 1 over.
Wow, that's so easy. I'm so happy. I'm just kidding.
So today is the last date that grades can be done. I think technically teachers